Introduction of microwave. Microwave refer to electromagnetic ray with frequency between 300 MHz and 300 GHz in the electromagnetic spectrum. When compared to the wave utilized in radio broadcasting, microwave are very tiny. Their frequency range is somewhere between radio and infrared radiation. Microwaves travel in straight line, and the troposphere has only a minor effect on them. Microwaves are ideal for wireless transmission of high bandwidth signal, satellite communication, radar signal, phone and navigational application are all typical use for microwave. Application of microwave. The most typical application are between 1 and 40 GHz. Microwave are ideal for high bandwidth wireless transmission, wireless LAN protocol such as Bluetooth. Microwave are extensively employed in radar system, which detect the range, distance, and other characteristics of sensing device, and mobile broadband application using microwave radiation. Where the control is being used. A control circuit for a microwave oven is disclosed which function to automatically control the running time of the microwave generator to enable it to run continuously during its cooking cycling or intermittently during its defrosting cycle. The timer control switch function to control the current flow from the source of electrical power to the microwave generator. The circuit also include a defrost control switch which function to cyclically open and close a series current path to the microwave generator.
The diagram on the slide show the microwave timer system is to obtain desired output. On block 1 show the input enter on the control panel, the time required before it is transferred on the second block, and then heat system is to produce heating on the food. On the block below state the resulting reaction at the output. On the slide show the transfer function system diagram block by Skillet. This calculation represents peak time, settling time, rise time, and percentage output, where the TP equally to 1.623, TS equally 1.200, and OS equally to 1.731.
So during our assignment, we use MATLAB to construct the graph in the system. So this is the graph shown by our MATLAB. So we can see value from the graph is just equal to value from our calculation, not many error. So this is the system transfer function to state space representation. So we can see the state space representation. We see the value is equal to u negative pi x square minus 10x equal 1. This is the stability of the system. Stability of the system can determine if the output is under control. The response has a value between 0 and 1. In the graph state response, we are able to control the stability of the system. This allows the system to reach a steady state. The stability of the system is located at amplitude at 0.1. The stability of the system took 1.1648 seconds to reach a steady state. So this is our calculation for our steady state error. So we get the final answer is equal to 2.
Okay, for the discussion, we were given the responsibility of picking one second ordering system in any engineering application. Based on this lab, the heating time control system on the microwave was chosen in this lab. A block diagram of the time heating control system can also be created. The required time heating in the block diagram is our input. We send a signal to a megatron, which generate a heating wave for temperature generation using a control panel. We write GS equal 1 over S2 plus 5S plus 10. This transfer function can be used for create step response graph. Peak time, increase time, completion times, and axis percentage may all be seen on this graph. For the conclusion, we know that the use of a heating system is vital for production control that is on the input that is channeled to the system output, so that the control system will be more organized and will receive the intended output based on the lab conducted at this season. The use of a PID controller has the advantage of being simple to implement. According to the system requirement, the system parameter might be calculated or designed. If the system setup is unknown, the PID gains may be calculated only on the basis of the tracking error.